Hello and thank you for joining us. Today we'll be introducing the first in a series of informative videos brought to you by Mars International. These videos will highlight manufacturing and product design tips, trends, and techniques across a variety of industry topics. Our video series will begin with the ABCs of IoT, an introduction to the core concepts of the Internet of Things. Our presenter today will be Brian Engelstein. He is the product manager for Cicada, which is our proprietary end-to-end IoT solution. Thank you again for joining us. Please be sure to subscribe to our channel for future video releases. Without any further delay, I will pass it over to Brian.
Thanks, Jason. Hello and welcome to the first Mars International informational video. This one is on Introduction to IoT Communication Technologies. I am Brian Engelstein. I am the product manager for Cicada at Mars, so I am the contact person for all IoT integration. Cicada is Mars's end-to-end IoT hardware and software solution. Now, let's begin with first principles. What is IoT? IoT stands for the Internet of Things. It is the act of connecting a physical device to the internet so it can be monitored or controlled remotely. It's a really useful topic, and I'm sure you've seen a lot about it recently. It seems at this point that everything from beds to ovens can be controlled through your phone or your Alexa. So, once you want to bring your product online, we need to move into IoT communication technologies. So what are IoT communication technologies? Quite simply, it's the way that a device in the field communicates with the server in the cloud so that it can be remotely monitored or controlled. This has nothing to do with how the cloud works, what data is being collected, and what's being sent. It's merely the method by which the device gets its data to the server and the server gets its data back to the device. Now, in this presentation, I'm going to be going over a few things. First, I will be showing you my technology rating categories, showing you the different ways that I look at technologies. Then we'll discuss the pros and cons of each commonly used technology. And finally, I will provide some real-world examples that Mars has dealt with in the past in order to help give you a better idea of how to apply these to your business. Now, beginning, these are my 5 technology rating categories. These are by no means exhaustive, but they are a good way to look at the different kinds of technology. The first one is transmission speed. This is how much data can be sent from the device to the server in a set amount of time. If you're doing something that involves very high data rates, such as video or pictures, then it behooves you to have a very high transmission speed. But if you're only sending strings of text or information, it doesn't need to be nearly as fast. Secondly, we have effective distance. This is how far the device can be from the router and still communicate with the server. So if you have a device that only needs to be in somebody's living room while their router is in their den, that's one thing, versus if you're trying to put something in a field in the middle of nowhere. Third is power requirement. This is how much power the device needs to make a communication with the server. This is especially important when your device doesn't have wall power, if it needs to be powered by a battery. So this can be important to keep in mind, especially if you're in a remote location. Fourth is setup complexity. This is how difficult it is for your end user to perform first-time setup on the device. An extremely easy device can be simply removed from its packaging and work, while something more complicated may require a dedicated team to get up and running. And finally, as always, the bottom line is cost. You need to, at the end of the day, you need to know what it's going to cost for your customers to determine if it's worth it to move online in general. And these can vary wildly between communication technologies. So these are the technologies we will be discussing today. Wi-Fi, Zigbee, and mesh networks in general, Bluetooth, both BLE and BT5, Cellular, LTE, and NB-IoT, and LoRa. So let's begin with the one most of you are probably familiar with, Wi-Fi. Wi-Fi uses a router, usually in a home or place of business, as a gateway to the internet. It is the most common IoT solution because most people have a Wi-Fi router set up in their home. In addition, if you want to connect to an Alexa or another device on a network, this is how you need to use it. It needs to be on the same network. However, it can be difficult to convince commercial properties to add devices to their network. I remember one time we were hired to build an IoT system for a company, and they wanted it to be Wi-Fi. But when we built a prototype for them and tried to set it up in their building, their IT department stopped us and said, "We will not let you put your devices on this network. This is a secure Wi-Fi network." So we went back to the company and said, "Look, we're building this system for you, and your own IT department won't let us set it up. Imagine what it's going to be like when you try to put this in other people's companies." In addition, some Wi-Fi networks have what is called a captive portal, which is when it asks you a secondary question. For example, in a hotel, beyond connecting to the Wi-Fi, sometimes you need to then fill out your room number and other information. IoT devices can sometimes have serious issues connecting to networks like this because they simply don't have the technology to bypass that login page. So let's go over my 5 points. The transmission speed on Wi-Fi is extremely high. This is why it's such the gold standard for home use. If you want to stream video or live anything, you want to be using Wi-Fi. In addition, its effective distance is pretty good. It does depend heavily on the router, but most homes and businesses have already done the heavy lifting for you and have put Wi-Fi where it needs to go within your location. However, it does have some concerns. The biggest one is Wi-Fi uses a lot of power. This is why you don't have a Wi-Fi communication just in the middle of nowhere. It really needs wall power to work for a long period of time. In addition, though it may not seem like it, Wi-Fi setup complexity can be very complicated, especially if you're not a big company. A lot of end users don't actually know their Wi-Fi passwords or Wi-Fi security types, and that can cause an issue as you're trying to get it installed. One advantage, though, is because Wi-Fi is so common, there's a lot of competition in the chipsets, and therefore the cost has gone down quite a bit. Wi-Fi is best just as a general catch-all, especially if you're working in somebody's home. As long as you're working in the end user space, Wi-Fi is almost always a good option to consider. Secondly, I'd like to talk about Zigbee and mesh networks in general. So first of all, what is a mesh network? Now, most networks you're familiar with are what are called a star network, where each node, which is any device, be it a computer or a cell phone or a fridge, connects individually to the gateway, and that gateway then connects to the internet. For example, in a home, all the devices communicate to the Wi-Fi router, which is the gateway, which then communicates to the internet. In a mesh network, each device is allowed to hop between devices, which then at least one of them needs to reach the gateway to reach the internet. This means that your devices can be out of the maximum range of your gateway and still communicate with the server. This is extremely useful because it means that if you have a lot of devices in a long area, say a 1.5 mile long tunnel or a water main, they can all continue to connect by hopping messages down the line so that they reach the server, versus building a Wi-Fi router every 50 feet or so. There are several competing protocols of networks that easily mesh. Zigbee is just the most common and the one we've worked with the most. A major competitor is Z-Wave, which is easier to set up than Zigbee, but is proprietary and will lock you into using the Z-Wave ecosystem. I recommend you look at the different competing protocols and pick the one that works best for your product. They do require a separate gateway and are best when there are multiple devices there. So let's go over the 5 points. The transmission speed for Zigbee is very low. However, because they're allowed to mesh, they tend to be best for small amounts of data that needs to travel far distances. As I said, for effective distance, because they can mesh, even though it says only 10 to 20 meters, they can reach miles, as long as you're not trying to send too much data. For power requirements, the cost of sending each individual message on Zigbee is very low. However, if you want to utilize the mesh network aspect, it does need to remain always on, versus Wi-Fi and other systems, which are allowed to turn off when they're not scheduled to send a message. This means that the power consumption can get very, very high, especially if you're on batteries. The setup complexity for these networks is extremely difficult, simply because they need to be connected to each other. I would highly recommend only setting up a Zigbee network if you have a dedicated team that can go in and set it up for you, so you don't need to rely on an end user that doesn't really understand your software. And the cost is roughly, it's medium. It's not the highest, but it's also not the lowest. I would recommend Zigbee when the meshing is a priority, when you have a large number of devices that you need to connect over a large amount of space, because you will save yourself money and heartache not dealing with a bunch of routers. Third, I'm going to go to one that I'm pretty sure most of you are also familiar with, Bluetooth. Bluetooth is a communication that works with a gateway, like the rest of them. However, this gateway tends to be something that is connected to another gateway. So Bluetooth traditionally will connect to a phone or a computer or another piece that has internet another way. It is native to most cell phones and computers. Most of you have probably dealt with Bluetooth in your car or through a hands-free headset. It plays very, very well and very low power, but that comes at the cost of having one of the lowest effective distances in the game. There are variations. BLE has even lower power, the lowest power of any communication we will discuss today by far, at the cost of having very low data rate and range. And BT5 is closer to Wi-Fi, but it costs a little bit more for what you get. So let's go to the 5 points for Bluetooth Classic. As I said, the transmission speed is very low. You really are not going to be able to transmit pictures or video or anything too complicated over Bluetooth, because your goal here is power. The effective distance is also very low. I'm sure you've all found this out with the new Bluetooth earbuds that are so popular. It's not that hard to get out of range of your phone. However, the power requirements are exceptionally low. So low that you can have these things running on batteries for months or even years and not have to change the batteries. It's very impressive. And the setup complexity is very low, assuming you have a phone or a computer with a native Bluetooth chip, which at this point most of them do. You just need to get it close enough, and the other product will take care of the rest. In addition, the cost is very low, about the same as Wi-Fi, because it's so popular and used in so many things. I recommend Bluetooth when you're pairing with another device. If you're building something that's supposed to stay near a phone at all times, Bluetooth is a fantastic way to save time and money without having to sacrifice cost or size. So next up, we are going to Cellular. Now, Cellular is not the monolith you might consider it when you take out your cell phone. Broadly speaking, there are two forms of cellular communication, LTE and Cat-M1 or NB-IoT. So we're going to go through both of them and talk about their differences. So we're going to start with LTE. LTE is what you have in your cell phone, and these are going to sound very familiar to any of you that have a smartphone. It requires a SIM card and a data plan through a carrier. Those are then plugged into the device, and the device is given all the benefits of a cell phone. It connects to a cell tower, it can move around, it can use GPS, it can use voice, it can auto set the time, it can roam between towers, it can do whatever your cell phone can do except for download apps. However, it does come with some costs. Because it needs to be on a network, it only works where that network is. And we've all run into dead zones on our cell phones or other devices, especially abroad. In addition, the module that you put into your device needs to be validated by the carrier, which is a time-consuming and expensive process unless you buy a chipset that has already been approved by that carrier. And you need to purchase your SIMs from them. So once you're in a carrier's network, you really tend to stay in that network for a long time. So let's go over the 5 points. The transmission speed is extremely high, almost as high as Wi-Fi. And as I'm sure you can tell with your phone, this is a good way to transmit video or whatever you want. But keep in mind the price, like a cell phone, does scale by data usage. So if you want to be constantly streaming live video, you're going to have to pay as though your cell phone was constantly streaming live video, which is not a cheap thing to do. In addition, the power requirements are extremely high because it is using so many features and communicating with such high data rates. You can do it with batteries, but you will have the battery life of, at most, a cell phone, which is to say 12 hours at a time. You can turn it off when you're not communicating, but I would recommend that you don't leave these out in the field for a month and expect them to work without a massive battery. On the other side, the setup complexity is extremely easy. Like a cell phone, once everything's all set up, when you give it to your end user, they plug in the SIM card and they turn it on and it connects to the cell tower, no problem. It just works. So if you want it to just turn on, LTE is the best way to do that. And of course, the cost is about $15 per module plus the monthly fees, which scale by how many devices you're putting in the field and how much you're transmitting per month. This can be on bulk data, so all of your devices count together, or per device, depending on which works out and what your carrier prefers. But this can become very expensive. I would recommend LTE for someone who really either desperately wants the simplicity or really needs the LTE features. If you're using GPS to track trucks that are traveling around, LTE will really be your only option. But keep in mind, you do pay for what you get. On the other side, NB-IoT, or Cat-M1, is more like a landline than a cell phone. It has all the cell features, but it cannot travel. It can't use GPS, at least not easily, and it can't use other high data features. It really reduces your feature list. While keeping the high-ish data rate, it reduces the data rate from LTE, and the ease of setup. So if you're setting something up in a location you can't easily get Wi-Fi to, but does have a cell signal, you can set this up because as long as it's not going to move, it still gets all of the benefits, though it still does have the cost like being validated by the carrier and purchasing a SIM and a monthly subscription. So going on to my 5 points, the transmission speed is medium-high. It is higher than almost every other communication method, but it is lower than LTE. That's because NB stands for narrow band. They have limited the bandwidth of the transmission and will not allow you to transmit as much data. In addition, the effective distance is almost the same. It's the same chipset. It's very similar. It's not the same chipset, but it is a very comparable chipset. The power requirement is high, just like LTE. These things use up a lot of juice, so I would highly recommend, especially for NB-IoT, plugging it into the wall because you're not moving anyway. So it will really benefit from that constant stream of power. Setup complexity is exactly the same as LTE. Take it out of the box, plug in the SIM, it works. And the cost is comparable to LTE, but you pay much lower monthly fees because the device isn't roaming, it has fewer features, it is simply an easier to use, cheaper LTE. So as I said before, I recommend NB-IoT over LTE if you don't need the features that LTE is giving you, because you will save a substantial amount of money moving to Cat-M1 or NB-IoT. If you're setting something up that just gets to sit there, say in a water treatment facility, as I've mentioned before, or a wind farm, NB-IoT can be ideal because it gives you all the features of cellular, it doesn't require a router, but it reduces your costs, and you don't need that transmission speed in order to make it work. So next up, and finally, we're going to talk about LoRa. LoRa is the new hotness, and it comes in a couple different flavors. So first, we're going to talk about the most common one, which is LoRa WAN. This is very similar to cellular, but instead of through the telecom companies, it's through the cable companies, at least in the US and parts of Europe. It requires a special LoRa network, which is very similar to a cell network, but isn't in all the places the cell network currently is. It can use a lot of the same features that cellular does, geolocation, setting time, but it doesn't have everything that the cell towers currently have. In addition, It actually is pretty cool. It works on a different wavelength than cellular does, so it is capable of traveling through metal, crowded city streets, and other locations that cellular or Wi-Fi can have a lot of difficulty traveling through. It can bypass them and still communicate with the server. It is new, but it's expanding quickly, and it is something of the new hotness in the industry. So we're going to look at the 5 points. The transmission speed is medium. You'll see it's considerably lower than cellular gives you, but that's still pretty good compared to, say, Bluetooth. The effective distance is incredibly high. This is the biggest advantage that LoRa gives you over other systems. As I said, because of its unique waveform, it can work 2 miles further away than cellular can. In addition, it can travel through a lot of different materials that cellular has a lot of trouble with. Its power requirements are substantially lower than cellular's as well, including Cat-M1 or NB-IoT, but it is still a substantial power investment, so don't expect it to last too long on battery power alone, unless your battery packs are very large, which is always an option. The setup complexity is easy. Like NB-IoT, you simply take it out of the box, plug in the card, and you're good to go. The cost is high. It is roughly $20 right now, but all of these are going down in price rapidly, and LoRa is going down faster than the rest. If I had made this presentation 6 months ago, this would have been $50, and now it's $20. I don't know where it's even going to be by the time this video goes up. So let's say, though, that LoRa isn't in the location you want to put your product, which is a real concern because those LoRa towers are not everywhere. Well, then you can just go for normal LoRa. So normal LoRa is to LoRa WAN what Wi-Fi is to cellular. You build your own small custom LoRa network, you connect it to the proprietary LoRa gateway, set it up, and then you get all the benefits of LoRa, the extremely long range, the ability to travel through materials, without having to connect to the cell tower. However, unlike Wi-Fi, you do lose that data rate, and because it's proprietary, you can increase your costs. So let's run through my 5 points again. As I said, the transmission speed does not change on these, but your effective distance can even get higher because once you're building it yourself, you're no longer quite as limited by the LoRa WAN infrastructure. If you want to build that infrastructure to, say, mesh, you're allowed to do that, make it even higher. The power requirements are medium, like I said earlier, not as high as, say, cellular, but not as low as Bluetooth. The biggest point for the LoRa is the setup complexity is hard. There are not a ton of out-of-the-box non-WAN LoRa solutions. So if you want to go this route, you really need to talk to somebody and have it fully built for you. Somebody like us, we can build it for you. We have experience. But LoRa is not for the faint of heart outside of LoRa WAN. And as I said, the cost is high, but if you build it yourself, you don't need to pay the monthly charge because you are not connecting to the WAN network. So now that we've gone through the different communication technologies, let's talk about the questions for choosing the right technology, because I just threw a lot of information at you. So you might be saying, well, that's great, but how am I going to pick from the list of technologies you just gave me? Well, you're always free to ask me. My information will be later on. But here are some key questions to keep in mind when you're thinking about what technology you should go for. What are my power requirements? Does the product need to be moved, or is it stationary? And by moved, I mean both away from a phone to a different state, away from your router is a good way to think about that. Because Bluetooth, going 20 feet is a move versus NB-IoT, where you really need to go 4 or 5 miles away before it counts as a move. Does my product require constant internet connection? I sometimes phrase this as, is this life-saving? will somebody die if I miss an update? How bad is it if something goes wrong? Is my product being set up by an end user or a trained professional? This is how complex your setup is allowed to be. If a setup is too complicated, like it was a lot in the early days of IoT, customers will simply bounce off unless they're really avid technophiles and want to get it set up, and they will be mean to you online. How reliable does your internet connection need to be? As I said before, is your product life-saving? Is your product used alongside a cell phone or a computer? Can you piggyback off of them, or do you need your own special connection? And of course, what price point do I want for my customer? Because depending on your product, different customers will pay different prices, and that of course always needs to be a concern. There's no point in building the best product in the world if no one's willing to buy it, as I'm sure we're all aware. So let's go over some examples of what Mars has done. I'll give you the product requirements, and you can think about it while we go over the 5 points, and then I'll talk about what we did. So our first case study is the Kimberly-Clark Onvation Smart Restroom System. This was a system to connect soap dispensers, paper towel dispensers, toilet paper dispensers, trash cans, and a whole bunch of other stuff to the internet, so janitors would be able to easily see what was out of paper and what needed to be refilled in large office buildings, which saved them a lot of time and effort. So this, as I said, is in large office buildings and places of business. We don't need to send messages to the devices, and those devices will regularly check in with how much paper towels do they have left. There's roughly 12 dispensers per restroom, 4 restrooms per floor, 30 floors in a building. Most of those are through concrete. And it's not life-saving, as much as it might feel that way if you're stuck in a toilet stall and have no toilet paper. So, what did we use? Well, let's go over the 5 points. Now, these are requirements. These are what we needed, not necessarily what we went with, because you'll see some of these are things that you may not want to say directly to your customers. So the transmission speed needed to be low. All we were doing was sending some numbers once every so often. The effective distance was reasonably high. A bathroom is about 10 to 15 feet, depending on how nice it is, and there were 4 of them on a floor, so they needed to communicate. However, there were lots of nodes. Each of the devices, the paper towel dispenser, the toilet paper dispenser, the trash can, and so on, were each an individual node, so we could potentially use that to our advantage. The power needed to be low, because most of these were going to be battery powered, and in many cases powered off the same power that would dispense paper towels or soap or other features. So you needed to make sure we were as unobtrusive as possible. This is where I said it doesn't need to be what you would tell your customer, because the setup complexity doesn't need to be hard, but it's allowed to be hard. When you're setting up a professional bathroom, you have a professional team of installers. It's these people's full-time job. You can send them to training. So the complexity can be harder. And the cost could be medium. This is not an essential product. People won't pay whatever it costs, but it is pretty cool and it does save a lot of money in the long run. So we didn't need to be impossibly price conscious. So what did we go for? We went for Zigbee. So Zigbee has low power and reasonably low cost, at least compared to, say, Cellular. We had a lot of devices, which means we could mesh them together and connect them to a single router that was on Cellular per restroom. It didn't require high data rates because, as I said, we were only sending numbers, so we could get away with the fact that Zigbee has low data rates. And we had professional installation, which meant the complexity of setting up the Zigbee network didn't matter as much. So let's go on to case study 2. Case study 2 is the Cigar Oasis Smart Cigar Humidor. This is a pretty cool one. It's a cigar humidor that measures the inside humidity and temperature and then reports it to your phone so you can remotely monitor it and control it. So these are in small businesses and people's homes. They report on a fixed schedule. There's only 1 or 2 devices per location, not 100 or 1,000, and they are not life-saving. So we don't need 100% uptime. If they miss a communication, it's not the end of the world. However, they are installed by end users, and these end users tend to not always be the most technical people. So, what did we use? Well, let's go to the 5 points. Transmission speed can be low if we need it to, because we're only sending numbers and occasionally alerts. We're not sending pictures of your cigars, as cool as that would be. The effective distance needs to be medium to even medium high, simply because these tend to be placed in somewhat out of the way places. Most end users keep their cigar humidors in their den or their garage or their attic or their basement, places where Wi-Fi or other information has trouble reaching. The power requirement is allowed to be high because these are exclusively run through wall outlets. These are not placed in the middle of nowhere. These are in people's houses and businesses. The setup complexity needs to be easy because it's being set up by end users and people who just want this thing to work so they can smoke their cigars. And the cost needs to be low because it's a product add-on, it's a luxury device, and people won't necessarily pay a lot for the privilege of getting a text message if their humidor is almost out of water. So we went for Wi-Fi, which I sort of gave away earlier, but it definitely was the right call here. Wi-Fi doesn't require a secondary router, your phone or a separate cellular router like Zigbee would, because we're already in people's homes and businesses, so they probably already have Wi-Fi set up. Power consumption doesn't matter because we're plugged in, and the data rate is high, so we can get away with even not using all of the data that we have access to. So I guess we could add in that picture of your cigars later on if we wanted to. End user installation means the process needs to be simple, and you might remember that I said that Wi-Fi is medium, but this is a case where you can't just look head to head, because even though cellular would do everything we wanted it to do already, not require a secondary router, have the high enough data rate to transfer, and be incredibly easy for an end user, it would multiply the cost of each device by 10 and add a monthly payment that the end user would probably need to pay. So you can't always get what you want. So you need to make some trade-offs. And in this case, we made the trade-off of slightly more complexity during setup in exchange for a lower price point for our end users. So the third and final case study, and this is the hardest one, the New York City subway IoT emergency lighting. This is a product that we built for New York City subway tunnels. It was emergency lights that would automatically check in and tell the maintenance crews if they were doing well or needed to be replaced, as well as some other information. And they're pretty cool. They replace needing to walk all the way down the tunnels and manually check to make sure everything is working okay. So this is a rough one. It is placed in a metal tube with a fast-moving train going by every few minutes. Anyone who knows how communication works knows that this is a nightmare for communication. Some advantages, though, is it does report on a schedule, but there are hundreds of devices spanning literal miles underground in a tunnel with a bunch of metal and dust and other debris running around. And these are life-saving. Remember how I said, does your product save lives? These products save lives. If these emergency lights would fail when we said they were okay, people could get hurt. When they need them, they need them. But they are installed by professionals. They don't just let anybody go down into those tunnels and mess with the lights. Though I did, which was kind of fun. So what do we use? Well, let's go over our requirements. Transmission speed can be low because, as with everything, we're simply communicating data. Some ones and some zeros. That's not too bad. You'll find a lot of products require pretty low transmission speed. The effective distance needs to be high. They need to be placed very far from the router, upwards of miles. And I've mentioned it a few times, but it is a big deal. These devices are in possibly the most inhospitable place ever. There's dust, there's metal, there's motion, there's other competing radios. It's crazy. So the setup complexity, the power requirements need to be low as well. These are battery powered. We're keeping an eye on that battery. And when it gets low, it needs to be replaced. So we don't want it to just be eating batteries constantly. In addition, the setup complexity can be hard. That's because we have professional people setting it up, and it doesn't need to be done by an end user who has no idea what to do. And the cost can be medium to even medium high, because this is a safety product. So whatever the device, if it saves lives and makes products easier, the government will pay for it. So what did we go for? I'll give you a little bit of time. We went for LoRa. I realized you could just pause the video. LoRa has long range, and as I mentioned, it is the best of all of the communication protocols at going through metal and dust, so it was kind of an obvious choice. It has low power consumption compared to using cellular, and because we're communicating with small amounts of data, the packets are not a concern. It is a professional installation, so we could use LoRa, not the WAN, because we had the ability to write our own code and trust that the people who are setting it up know what they're doing and can be taught. And it is extremely reliable at long ranges. You may remember that LoRa had by far the longest range of any technology on this list. So just in case, that is the best one for getting the information back when the information matters. And the golden rule, don't be afraid to ask for help. Mars has a team of engineers here to help you. They've got me. We've got 20 engineers in all different specialties. If you come in or send me an email or a phone call, I am happy to discuss your options, to look through this list with you, offer suggestions, and we will figure this out and find the one that is best for you. So I hope you enjoyed this video. I hope you learned something. Please feel free to like, comment, and subscribe, which I've always wanted to say. And we will be back soon for the next video.